Organic Chemistry. We were studying the alcohols topic. Some of the chemical reactions we have seen. Before going for the distinctions among the various types of alcohols, we have one more reaction, that is reaction with ammonia. So when you take a molecule of this ethyl alcohol or any alcohol in presence of aluminium oxide, heated aluminium oxide, it will react with ammonia to give rise to this primary amine C2H5NH2 along with the formation of water. So this is one more important reaction to convert an alcohol into corresponding amine. Ethyl alcohol reacts with ammonia to give rise to ethylamine with the elimination of water molecule. This aluminium oxide acts as a dehydrating agent. Now let us go for the distinctions or distinguishing tests of primary, secondary and tertiary alcohols. We have seen in the previous video the primary alcohols contain at least 2 hydrogen atoms on the carbon carrying the OH group. So the general formula for a primary alcohol we can write as RCH2OH. For a secondary alcohol, this is primary. For a secondary alcohol, there is only 1 hydrogen atom attached to this carbon carrying the OH group. It is secondary. The tertiary alcohols do not contain any hydrogen atom attached to this OH group. So this is tertiary, that is indicated as 3 dot. So to distinguish these primary, secondary and tertiary alcohols, we use various tests. One among that one is this Lucas test. This Lucas reagent is anhydrous zinc chloride and dry HCl gas. So when we use this reagent zinc chloride and HCl, that test is named as the Lucas test. When we take this primary alcohol with Lucas reagent, this primary alcohol gives a turbidity only on heating. This indicates that primary alcohols are less reactive towards the zinc chloride and anhydrous zinc chloride and HCl. Actual reaction is OH group will be replaced by the halogen atom, that we have seen in the chemical test. But primary alcohols require heating because the reactivity of the primary carbon atom is very less as compared to second one. This secondary alcohol reacts with the Lucas reagent to give rise to turbidity after 5 minutes. Turbidity is again forming the corresponding chloride. But tertiary alcohol on adding this Lucas reagent, it gives a turbidity immediately. This shows that tertiary alcohols are highly reactive towards this Lucas test or Lucas reagent. The mixture of this anhydrous zinc chloride and dry HCl is called as the Lucas reagent. So with Lucas reagent we get primary alcohol giving the turbidity only after heating. For secondary alcohol, the turbidity appears only after 5 minutes. So comparing to primary alcohol, secondary alcohols are reactive. But the reactivity is less as compared to this tertiary alcohol. Tertiary alcohols give immediately the turbidity due to formation of the corresponding chlorides. The second one is dehydrogenation reaction. Dehydrogenation reaction. The dehydrogenation is elimination of the hydrogen molecule, one from the hydrogen atom and of the OH group and another from the carbon atom. We know that primary alcohols contain 2 hydrogen atoms to this carbon, while secondary alcohols contain only 1 hydrogen. Tertiary alcohols do not contain any hydrogen. So, the reagent used for the dehydrogenation is either heated copper or silver metal. So, when any alcohol vapor is passed over the heated copper or silver metal, it gives rise to the product with the dehydrogenation reaction. So, vapors of alcohol are passed over heated copper or silver metal. Then what happens is, in case of the primary alcohol, it undergoes dehydration to give rise to an aldehyde. For example, if you take this CH3CH2OH, this on dehydrogenation by passing over heated copper or silver, it gives rise to CH3CHO with the liberation of the hydrogen gas. Aldehydes can be detected by using various reagents like tolerance reagent, filling solution, etc. While secondary alcohol gives rise to a ketone. For example, if you take this CH3, CHOH, CS3, isopropyl alcohol is a secondary alcohol. This on dehydrogenation by using copper or silver, it will give rise to CH3, C double bond O, CH3, along with the formation of hydrogen. Tertiary alcohols do not easily undergo dehydrogenation, but they undergo dehydration, giving rise to dehydration to give an alkene. For example, if you take this CH3, COH, CH3, CS3, this is called tertiary butyl alcohol. This on heating with copper or silver will not undergo dehydrogenation, but it undergoes dehydration to give rise to an alkene. So it gives rise to CH3, C double bond CH2, CH3, along with the formation of water molecule. So one hydrogen from this one and OH group from this one, they are eliminated as a molecule of water. So the product obtained is an alkene along with the dehydration. So these are the two important tests to distinguish primary, secondary and tertiary alcohols. The next two tests, one is Victor-Meyer's test and another oxidation reaction, that we shall see in the next video. Thank you.